Welcome to Lesson 1, Evaluate and Use Nth Roots. Our objectives are to find nth roots and to evaluate expressions with rational exponents. Let's go ahead and review a little bit as far as terminology so you'll understand what we're talking about. What's an nth root? Well, the nth root is just the index of this radical sign here. Typically, we always say square root, but that means that the index n right here is a 2. And because it's standard, we don't write the 2. But just know that there are different types of roots we can take, like the third root or the fourth root. And that root is called the index. The number inside the radical sign is typically called the radicand, and obviously we have the radical sign. Let's look at some examples. Here we need to find the nth roots. Well, in this first problem, this is pretty typical. You can look at this and say, well, that's the square root. And you know that because there is no index here. But I could write a small 2 right here and it means the same thing. It means take the square root. So what we're asking ourselves is, what number can we square in order to get 4? That's what the square root means. The cube root means, okay, what number can we raise to the third power and still get 27? And you can see the pattern. On the fourth root, what number can we raise to the fourth power and get 48? Well, if we look at the square root of 4, you've seen that many times, and you know that the square root of 4 is actually 2. But let's look at another way to write these radicals. If we want to take the square root of 4, we can also write this in a different way. We can write this as 4 raised to the 1/2 power. So the denominator down here, this is where we put the root or the index. Another way to write a radical, again, is to put the base right here, or the radicand, and then raise it to the index power. So let's look at 27 right here. We want to take the cube root of 27. We can rewrite that as 27 raised to the 1/3 power. It means exactly the same thing. We want to take the cube root of 27. And then with 48, we can do that as well. So we can write this as 48 raised to the 1/4 power. So why do we want to do that? Why would we want to rewrite a radical as an exponent? Well, you will see that in the upcoming lessons, because when we are combining exponential numbers and terms together, it's easier to write them like this instead of as radicals. It's much easier to take 4 to the 1/2 power times 4 to the 3/2 power than it is to take the square root of 4 and multiply that times the square root of 3 raised to some power. So by changing the radical to an exponent, it makes it easier for us to do operations with rational exponents. Okay, let's go ahead and continue to solve these problems. So we already know that 4 raised to the 1/2 power, or the square root of 4, is just 2. Okay, let's look at this one. So the cube root of 27. So we had to ask ourselves, what number raised to the 3rd power is going to get 27? And remember, we wrote this as 27 to the 1/3 power. Well, 2 times 2 times 2 is 8. So let's try 3. 3 times 3 is 9, and 9 times 3 is 27. So we know that 3 raised to the 3rd power is going to give us that 27. So the answer is 3. Let's look at 48. 48 to the 1/4 power, or the cube root of 48. That's a little more difficult. That's hard for me to do in my head. So another strategy that you can do is you can take the prime factorization of that number, which we'll go ahead and do that right now. 48 is going to be 2, so I'm always going to take the smallest number first, times 24. And then we can break 24 down into 2 times 12, and 12 into 2 times 6, and 6 into 2 times 3. Now I have all my prime factorizations. We'll circle those. We have a 2, a 2, a third 2, a fourth 2, and a 3. So if I multiply all those together, I should get 48. Now let's go ahead and write rewrite the fourth root of 48 with these in there. So what do we have now? We have the fourth root of, we have 1, 2, 3, 4 2's, so we can write that as 2 to the fourth power times 3. If I had 5 2's, I would still write 2 to the fourth power, but then I would put times 2. The goal is to write these prime factorizations in the same power as the root. That way now I can take the fourth root of 2 to the fourth power as just 2, which leaves a 3 inside my root. So our answer to this problem is 2 times the cube root of 3. Or if I wanted to write it as a fractional exponent, I could write it as 2 times 3 to the 1/4 power. All right, let's look at some more examples. In this slide now, I'm taking the fifth root of a negative number. And if you remember, whenever you take the square root of a negative number, the negative always has to come out as I, an imaginary number, because we don't have a number that we can square and become a negative. But we do have numbers that we can take to the fifth power or the third power or any odd power and have a negative. Okay, well, let's practice rewriting first. So we can rewrite this as negative 32 raised to the 1/5 power. And again, just a good skill to have because you'll be using that skill when we start solving exponential equations. Okay, so let's take negative 32 and think about what that might be, the fifth root. Well, 2 times 2 times 2 times 2 times 2, 5 2's does give us 32. We need it to be negative, however. What about negative 2? Let's try that. Okay, so we write our 5 negative 2's, 1, 2, 3, 4, 5, and let's see if that multiplies to give us negative 32. Well, negative 2 times negative 2 is 4, so we have another 4, and then here we just have negative 2. Negative 4 times negative 4 is 16, and a positive 16 times a negative 2 is in fact negative 32. So, for your understanding, anytime we're taking an odd root of a negative number, we can do that and still get a real answer. So, the answer here is going to be negative 2. All right, let's look down here. We have 25 raised to the 3/2 power. You probably haven't seen that before, so let's look at what that means. The 3 on top is a power, and the 2 on the bottom is our root. Remember that we rewrote negative 32 as negative 32 to the 1/5 power. We can take that index, put that as a denominator, and that's our root. So we're still doing that. So this 2 means we need to take the square root of 25. But the 3 on top is the power we are raising. If we were to write this as a radical, we would rewrite this as the square root of 25 all raised to the 3rd power. This is going to be important to remember, so you should write this down in your notes. B represents the base, N is the index or root, which is the denominator, and M is the power that you're raising everything to. Now, order doesn't matter. It doesn't matter if you raise it to the power first and then take the root, or vice versa. But I tend to always like to take the root first. That way it makes the number smaller and easier to work with. Okay, let's look at our last example here. So let's rewrite this in order to write it as an exponent. So what this looks like then is negative 64 raised to the, now here's 3, this is the root we want to take, so that's the denominator, and 4 is our power. So we would raise it to the 4/3 power. How do we do this? Well, like I said, I always like to take the root first. So let's take the cube root of negative 64. And if we look at how negative 64 breaks down, it breaks down into negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is positive 16, and positive 16 times negative 4 is negative 64. So the cube root of negative 64 is in fact negative 4. But then we need to take the negative 4 and raise that to the fourth power. So that would be 4 negative 4s. And if we multiply negative 4 times negative 4, we get positive 16. And then times another positive 16, we would get 256. That is how you solve bases that have rational exponents. Take the root, which is in the denominator, and then raise that answer to the power, which is in the numerator. Let's try one last set of examples before we wrap up. Okay, let's find the nth roots. Well, remember that this is all 16x to the fifth, all raised to the 1/3 power. We can rewrite that if we want. All right, so if I don't know the third root of 16, then I'm going to need to break it down into its prime factorizations. So 2 times 8, 2 times 4, and 2 times 2. Now I'm going to rewrite this inside my radical. So I've written 1, 2, 3, 4 2's inside my radical, and then I have 5 x's. So I've broken them apart. Now we need to summarize, and the goal when you're summarizing is to put things in groups of 3 because we're taking the cube root. Well, let's look at that. We have 1, 2, 3 2's here, so I'll write that as 2 cubed. We have 1 left over. We can't forget about that, but I'm going to write it separately. Here we have 1, 2, 3 x's, so I'm going to write that first group as x cubed, and then I have 2 left over, so I'll write that as x squared. Now, let's go ahead and take cube roots, when we can easily see which ones they are, the ones that are to the 3rd power. So we've got 2 to the 3rd power, that's one of them. And then we've got x to the 3rd power, that's the second one. We're going to go ahead and pull those out, and then everything else will stay in the radical, and we'll still need to take the cube root of 2 and x squared. And that would be our final answer. So 2x times the cube root of 2x squared. Let's look at our second example. In this example, again, we would need to break down the 128 into its prime factorizations. So let's go ahead and do that now. Okay, so we can see that I have 1, 2, 3, 4, 5, 6, 7 2's. And look at my exponent here. I'm taking the 7th root of 128 and raising that to the 5th power. Well, this is pretty easy, right? Because 1, 2, 3, 4, 5, 6, 7 2's basically means I have 2 to the 7th power, and I'm going to take the 7th root of that and raise it to the 5th power. Well, the 7th root of 2 to the 7 is just 2. And then I need to raise it to the 5th power. 2 to the 5th power is 5 2's all multiplied together, and that gives me 32. Okay, let's try our last problem. So again, we have a big number, and we want to go ahead and factor this into its smallest prime factorizations. All right, I've broken it all the way down, and notice these are prime numbers, so they cannot be broken down anymore. They're only divisible by 1 in themselves. How many 2's do I have? I have 1, 2 2's, so I'm going to write 2 squared. Not enough for 4. How many 3's do I have? 1, 2, 3, 4, so I have 3 to the 4th. Now, instead of writing 6 x's and 8 y's like we did here, I'm just going to break these apart. I'm going to pull out 4's because we want to take the 4th root. So if I do that, I have x to the 4th, and then what's left over? 2 are left over, so I still have to include those under my radical. Let's look at y. I can break that into y to the 4th, and how many do I have left over? I still have 4, so I need to write those too. Okay, now we're ready to pull out anything that is raised to the 4th power. Anything to the 4th power is the cube root. So here we have 3 to the 4th power, so I can pull out the 3. I have x to the 4th power, I can pull out an x. I have 1y here to the 4th power, I can pull that one out. And I have another one to the 4th power, I can pull that out as well. Now I just need to write what's left. So that would be the fourth root of 2 squared. I'm going to simplify that into 4. And then x squared. And that's all I have left. Now, one thing I could do is y times y is y squared, so I might want to write that more simply as 3xy squared times the fourth root of 4x squared. And that concludes our lesson today with a bunch of examples on how to find nth roots and evaluate radicals that have nth roots. So at this point, you ought to be able to find the nth roots and evaluate expressions with rational exponents.